All right. So I want to explain to you guys a little bit more about vectors because I feel like I completely confused you guys when we had our lesson today because in the heat of the moment, I was totally just combobulated myself. So I want to go over and kind of sum up vectors and then do two examples. One is going to be just taking one vector apart, and then the other one is going to be adding two vectors together. So let's start over, and please forgive me for totally botching today. So let's go ahead and get started into this problem. All right, so the first thing that I want to say, so let's kind of look at this in terms of like one vector. So if we looked at, say, a vector, and let's say that our vector was, I have some notes here. Let's say that it was a car and it was moving with a velocity of 25.0 meters per second at a 45-degree angle. And so we want to figure out what are the X and Y components of this movement. So if I were to plot this, I'm just going to kind of do a basic and not do the whole thing. So here's X, here's Y. If I were to plot what I have here, it might look something like this. And this angle right here would be 45 degrees. This vector represents that the velocity is 25.0 meters per second. And what we can do is that we can break this vector up into X and Y components. So we can find the velocity in the Y direction and then the velocity in the X direction. We'll call that Vy and Vx. So we can do it this way. Now, what I got so backwards in our discussion today was my equations. And so here are the equations. So these are the equations you should know. If you want to find it in the X direction, let's start with the Y. Vy, so in the Y direction, you were going to use the velocity or the vector sine theta, okay? If you want to figure it out in the X direction, you're going to use V cosine theta. So you have those two equations if I wanted to break this up into the X and Y direction. The other thing that I want, or let's go ahead and solve this and then we'll add another vector, and then once we add another vector, some more equations come into play. So let's go ahead and figure out what are the X and Y components of this one vector right here. So if I were to plug this in, so I would have Vy equals 25.0 meters per second sine 45 degrees. And let me grab my calculator really fast. So sine 45 times 25 is going to be Vy is going to be 17 point, I'm going to say 8 meters per second. So that is the velocity in that Y direction. Now, if I were to find my Vx, same numbers, because we're still dealing with that vector, that 25 meters per second, and this is going to be cosine 45 degrees. So we have those two. Sorry, I just thought I switched it up backwards again, and that would have been bad, but I did it. We're good. Okay. Now, if you plug that in, you actually get the same answer is still going to be 17.8, and that's because we're at 45 degrees. So that is the X and Y component of that vector. Now, why does this become important? Well, what if we have two vectors that we want to know, like, their overall motion? If we were to add two vectors together. Well, the only way that we could add two vectors together is to separate them into their X and Y components. So break them apart, kind of deconstruct them, and then add together those individual X and Y factors. So let's go ahead and do that. So we'll move up, and I have an example for us to do. So let's say that we want to add these two vectors together. So what I have is I have vector 1. Vector 1 has a magnitude of 53.0 meters at a 20-degree angle. And vector 2 has a magnitude of 34 meters at a 63-degree angle. Okay, and we want to add these. So the question might be, what is the resultant vector? Whoops, that got, there you go. What is the resultant vector? So when they say resultant vector, they're pretty much just asking you to add those vectors together. What is the overall vector? What is this overall gonna look like? So let's go ahead and first sketch this out just so we can get an idea of what this looks like. So it does not matter what vector you start with. I'm going to start with vector number 1 just because why not? So we have 53 meters at a 20-degree angle. So 20 degrees isn't too big. Let's say that this is 20 degrees. And again, this is a 53. Did I say 53? Yep, 53 meters. Okay. Now what we want to do is we want to draw the next vector at the tip of this vector that I have right here. So it's almost like we're going to draw another set of coordinates right on top of it. And I'm going to draw my next vector according to that coordinate system. So now I have a 63 degrees. So let's say 63. Let's say that's 63. So this angle right here is 63. And this is a 34 meters. Okay. So what I am trying to find, and this is not going to be straight because I am not good. Oh, that's not too bad. So what I get is this green dotted vector, and that is my resultant vector. And I'm going to call that V total, like my total vector. Okay. So what I need to do is I need to break my vector 1 and vector 2 into its x and y components, just like we did in the previous problem. But then what we need to do is we need to then combine those x and y values together to get the total. And so I'll show you guys the 2 equations that you need for that. So let's go ahead and do that step and let's organize our work. So let's say that we have vector 1. And we want to find Vy. So Vy is our sine, and that's what I kept getting so confused. I don't know why I had it in my mind the other way around. Okay, 53.0 meters times sine 20 degrees. And then we're going to have Vx is going to be 53.0 meters times cosine 20 degrees. So let's figure out what these two are. Grab my handy dandy calculator, times 53. So this is going to be 18 point, let's say 1. 20 cosine times 53. This is going to be 49.8. All right. So there are my Vy and Vx, and you know what? I'm going to be more specific. I'm going to put 1, and that's because you put the subscripts to help identify what that vector is. So by putting the y1, I'm saying that's a y component of vector 1. So just trying to be more specific with that. Now let's go ahead and break apart vector 2. We're going to do the same thing. So Vy, comma 2, and this is going to be 34 meters, and this is going to be sine 63 degrees. And then we're going to have Vx2, and this is going to be 34.0 meters cosine 20 degrees. Okay, so let's go ahead and wait. I put 20. 63. Okay. Now let's go ahead and solve this. 63 sine times 34. This is going to be 30 point, let's round that up, 3. And this is going to be 63 cosine times 34, and this is going to be 15.4. So now what we're going to do is we need the total x value and the total y value, and all we need to do is add those together. So looking at this, I'm going to add these together. So my v total is going to be, my vx total is going to be vx1 plus v, why am I doing x? I just really want to confuse you guys, I think. I really want to make this as hard as I can for you guys, so that's why I'm doing it this way. Okay, and then vy2 plus vy1. Then we're going to add these two together, and this is going to be v total x. This is going to be vx2 plus vx1. And again, it doesn't matter if you do 1 or 2, they're the same thing. So if we were to get our total, v total y, 18.1 plus 30.3, this is going to be 48.4, and it's meters, just so you know. And then we're going to have 49.8 plus 15.4, and then v total x is going to be 65.2 meters. Okay, so that is our x and y component of that green line. Now what we need to do is we need to combine this into one. And to combine these, we need to use Pythagorean theorem. So we need to say that our v total is going to be equal to our x total squared plus our y total squared. So if I were to write this out in an equation, you guys know like a squared plus b squared equals c squared. Or if we were applying these variables, I might say v total y squared plus v total x squared equals v total squared. So that's going to be the equation that we use for this. So let's go ahead and plug that in. And this is what's going to look like. So we're going to have 48.4 meters squared plus 65.2 meters squared is going to equal, I'm going to go ahead and move my, my square root this over, okay? So that means I'm going to take the square root of this, and this is going to be v total. Okay, so let's go ahead and figure out what our v total is. So we have 48.4 squared plus 65.2 squared. And then we want to take the square root of that. So my v total is 81.2 meters. So that is like the length of that vector. So that's that length. Now notice, just like with our other vectors, we also need to have an angle. So we need to be able to have both the length of that and then the angle at which that vector is going. And in order to find that angle, our angle is going to equal to tangent inverse tangent inverse tangent, and that is going to be vy over vx, or v, we can put the little total sign there, the total. So we have that equation. So now we're going to find our angle. So if I were to plug this in, tangent -1, vy, which is 48.4 meters, over my vx, which is 65.2 meters. And so 48.4 divided by 65.2 And I'm going to take the inverse tangent, and my angle is 36.6 degrees. Okay, so if we go back up, I now know that this angle is 36.6 degrees? 36.6? Yeah, and the length is 81.2. So, and that's gonna be 81.2. And hopefully by just looking at that and applying that angle to this diagram, that kind of makes sense, that it should be obviously an angle greater than 20 degrees when you look at that resultant vector. So hopefully that vector kind of makes sense. So there's that problem for you guys. I am so sorry for confusing you. I needed to get my thoughts together. It scrambled me up too. So hopefully that helps, and hopefully that explains some things. So feel free to go back and redo any of those homework problems, or redo that breakout or that bell work problem that we had. And hopefully this helps explain things. Oh, one last thing. I just kind of want to sum up our equations, because sometimes that's helpful, just have all your equations in one place. So if we want to find the x and y components, we're going to be using that idea that Vy equals V sine theta. Vx is going to equal V cosine theta. If we want to combine these two, we're going to use V total is going to squared is going to equal Vy squared plus Vx squared. So that's kind of putting them back together. Now, again, you might have more than one to get that resultant vector like we did in the previous problem. And then to find the angle, our angle equals tangent inverse Vy over Vx. So there you go. Hopefully that helps clear up any problems that I totally created for you guys during our lesson today.